Hello everyone, this is Palash. I hope you have watched the previous video on the syllogistic arguments theory and a bit of questions towards the last that we solved. Today we are going to practice upon certain 15 questions which are based on the concepts that we discussed, we learned in the previous video. In this video, I'm going to solve only, just a quick revision before we move towards the theory that we discussed in the previous class. Uh, I discussed what are the four important things that you need to remember with respect to the quantity and quality of the statements, which is universal positive, universal negative, particular positive, and particular negative, which are in cases like all A are B, no A is B, some A are B, and some A are not B. Any statement, if it doesn't look like it, needs to be converted into a logical equivalent of made like these four statements, and the immediate conclusions that can be driven from them needs to be memorized, which are some B are A, some A are B, no B is A, some A are not B, some A are not, some B are not A, and from some A are B we can derive some B are A, and then some A are not B gives us no immediate conclusion. Also, a memory note was upon all A R B is not equal to all B R A. So, quite few things that we need to remember. I hope you remember them. Some basic rules to remember. Again, recapping, reconnecting it from the first class. Affirmative statements give us affirmative conclusions. Negative statements give us negative conclusions. Universal statements give us universal or particular conclusions. Particular statements give us particular conclusions. The key mantra of solving syllogism from my way is that if something is claimed to be definitely true, it needs to be true for all the logical possibilities. That means it must not be false for even one logical possibility, and hence today in applicative class we will try and consider that one logical possibility where it will be false. If we are not able to falsify it, it's definitely going to be true. Otherwise, it's definitely a false statement. Something probably claimed is, on the other hand, true if there is one logical possibility that confirms it. So, for our solving purpose, we're just going to apply the same funda that for positive conclusions, we are going to draw minimum intersection diagram, which will check the falsity of the claim, and for negative conclusions we will try to draw the maximum intersection diagram, which will check the positive claim or the truth of the claim. In similar cases, we are going to consider if something probably claimed needs to be true for minimum one possibility, and if something is claimed to be definitely true, it needs to be true for all logical possibilities. Last keynote that we also discussed and emphasized, because there are a lot of possibilities that comes with respect to sum, was that sum must be considered at least one and not all. Logical possibilities of each type were these ones. I think for all A R B, it's a subset or an equal set. For a no A is B, obviously these two things are not going to intersect. So one quick possibility. Some A R B, as I said, out of the 6 possibilities, these 4 are some things that the 5 which we need to consider, the sum A R B, one minimum A being B, some of them being B, all of them A being a superset, but still some of the A being B, and then A being an equal set, and then A being a subset. So the 5 possibilities of the sum and the 4 possibilities of the sum not, being sum as minimum 1, not being A, the A that definitely are not B, the all of the A that are not B, and some of the A that are not B. So just keep that in mind. I think these are the quick revisions. Now, also we discussed 6 necessary conditions for the definite conclusion. That 2 positives gives us a positive, 1 positive, 1 negative gives us a negative, and 2 negatives gives us nothing. Nothing in sense, no mediate conclusion. No mediate conclusion is possible. However, the immediate conclusions are definitely can be retrieved. Similarly, 2 universals combine to give us a universal set or a particular set. A universal and a particular can give us only a particular, and again 2 particulars combine to give us a nothing. Nothing again represents a mediate conclusion. What is a mediate conclusion? A mediate conclusion comes from 2 or more than 2 conclusions or 2 statements that are given to us. Remember, they can always give us immediate conclusions at that time. So without much ado, uh, I think let's quickly also revise what was the drawing diagram tips. Try to draw the negative statements, that is no, not, none first. Draw then the universals. If there is no negative and you have a confusion between a universal and a particular, try to draw the universal first. And then for positive conclusions validity check, draw the least intersection diagram. And for negative conclusions validity check, draw the maximum intersection diagram. So these are the four tips that I'm going to follow today in making the diagrams. Just remember them and let's solve certain questions and see how we can reach out to the quick answers. Okay, so we say some fruits are not mangoes and some mangoes are guavas. As I said, draw the negative first. Let's draw for this one. Some fruits are not mangoes. Okay, so I'm going to draw a diagram which says that these are the fruits and these part of the fruits are not the mangoes, so they are outside the mango, so definitely the particular negative. And then we say some mangoes are guava, so now least intersection diagram. Let's say these are the part of mangoes that are guavas. Now let's check for this my least intersection diagram. Can I check no guava is fruit, none of the guava is fruit? Yeah, in this case it's true, but remember for a negative conclusion we must draw a maximum intersection diagram, because at least intersection it might be true, and therefore now we have to check it for that are none of the guavas fruit. In any possibility can we falsify it? Let's check the minimum maximum possibility. Let's say if this was my fruit and this was my mango, I could have said that all these are the fruits that are not mangoes. See, remember the first one? This is the MID for the maximum intersection diagram for the first one. In this case, now I move the second. All the mangoes, some mangoes are guavas, some of the mangoes are guavas now. Some of the mangoes are guavas. Guavas can have been even a bigger set. Okay, in this possibility, can I say no guava is a fruit, because all of the guavas technically become fruit. So there is a possibility which can falsify it, and therefore this claim is not true. Now you might be wondering, why is this happening? Why are you not drawing only one diagram? Please remember that for negative conclusions we should check for maximum intersections. For positive conclusions we should check for least intersection diagrams, and therefore for a next one, which is a positive conclusion that all fruits are guavas, are all fruits guavas? I think definitely not. We clearly get the answer from the least intersection diagram, and therefore in this case the answer is C, which means neither one nor two false. Let's move to the next question. Okay, you can pause the video, solve it on your own, and then I'm gonna solve it. So you go ahead, pause the video. All right, let's resume. No pot is mat, no pot is bat. Now, two negative conclusions are given, that there is a pot that is not supposed to intersect mat, and then the pot is also not intersecting bat, but bat can intersect mat. Okay, so there is this bat as a possibility that I can make. There is also one possibility of bat that can be like this, and there can be also one other possibility of the bat which can be like this. Okay, now pot is not supposed to touch bat, but bat can touch mat. There is no relationship told between bat and mat, so we have to consider the possibilities of it. Now, let's look at the first one, which says no mat is bat. So none of the mat is going to be bat, which is true for bat 1, but not true for bat 2 and bat 3. And as I said, for the maximum intersection diagram, so this is the maximum intersection diagram, which definitely refutes this possibility. So this is a false claim that he's making. And then some bats are mats, some bats are mats is true for this case, even true for this case, but definitely not true for some bats being mats. and therefore is not the correct answer for this one. This one also falls at my LID, that is the least intersection diagram, right? So for a positive claim, least intersection diagram; for a negative claim, the maximum intersection diagram. So again, the answer comes as C, neither one nor two follows. Let's move quickly to the third question. Again, pause the video, solve for a while, and then I discuss. Let's resume. All phones are cameras. All phones are cameras. Some cameras are not televisions. So some of the cameras are not included into television. So let's say these are my all cameras which are not televisions. So these are the cameras that are not televisions. Now, can I say none of the phone is television? None of the phone is television. In this diagram, yes, we can say it, because again, you made it a least intersection diagram. Or can I say all the phones are television? Can I say all phones are television? No, definitely not. So in my least intersection diagram, I can deny this one, that all the phones are not necessarily television. So this is definitely a wrong choice. But for no, I have to check for the maximum diagram. And let's therefore draw a negative diagram first, that's saying some cameras are not television. So, okay, these are my cameras and which are not televisions. So let's say the televisions is here, and then all the phones are cameras. Now all the phones are cameras, so phones are also inside the camera, and therefore a phone can be here, a phone can be here, phone can be equal to TV as well, and a phone can be equal to here as well, can be equal to camera as well, because all the phones are cameras, right? Now, in this maximum intersection diagram, can I say that no phone is television? I think all the phones become television. Okay, all the phones can also become television, so this is also lying. So again, the answer goes as C, that neither of the two are valid. I hope you've understood it, that I've checked it at MID, and this one I checked it at least intersection diagram. Why am I checking and making two diagrams? Because it is encompassing all the two. Okay, there is a rare chance that in your exam all the conclusions can be all the conclusions can be positive, or all the conclusions can be negative. So I'm just picking up those kind of questions which have both. So only two diagrams will be sufficing to realize that which is the right answer. Let's move to the next. Some parrots are monkeys, some monkeys are tiger. Okay, so we quickly know that particular positive gives us no immediate conclusion. So we cannot say anything about parrot and tiger. So any conclusion about parrot and tiger is definitely false. How do I realize this? I quickly remember that this is the rule, that particular gives us nothing mediate. It only gets reversed. So I did not need to draw 6 possibilities of each and then check. So all I'm going to say is the immediate conclusion follows or not. So some tigers are monkeys. So yes, some tigers are monkeys is only coming from this, and therefore definitely a valid conclusion. So in this case, the answer is Bombay. Without any diagram, I drew it because I just have memorized that the condition about definite conclusions always follow. Let's move to the next one. Okay, again, some and some, but this time some and some not. So again, I remember P positive, P negative can only give us a nothing in sense. P negative can never be reversed, and P positive can only give us a P positive. It cannot give us anything in combination. So I think a universal negative is definitely out of the window. And then some belts are wheels is something also that we cannot say, because this is positive and coming from a combination of belt and wheel. How did I find that out? I think belt is 1, roller is 2, and then wheel is 3rd. So this is combining the 1 and the 3. Okay, so definitely none of them were going to be valid. Again, without diagram, I quickly solved it. Okay, so C is neither 1 nor 2 is going to be followed. Let's move ahead. You can pause the video, solve it on your own, and then see my solutions of it. All bulbs are wires. All bulbs are wires, and all wires are cables. All wires are cables. Now, all the bulbs are cables, all the bulbs are cables. I think definitely this is my least intersection diagram. This is my positive way. So I will prefer the LID, which is the least intersection diagram. So all bulbs are definitely cables, so valid. And then some cables are bulbs. Some cables are bulbs is absolutely valid. Both of them are valid, and therefore answer is Delhi. The correct answer is going to be Delhi. Next question. All birds are fishes. Again, pause the video, try it on your own, and then we can come back. No, all birds are fishes. All fishes, all birds are also hens. Now, this is very interesting. All the birds are fishes also, and all the birds are hens. Now, if I'm going to decide and draw this kind of diagram, it might land me into a problem, because then I do not know which set is bigger, because bird is an inclusive part of all. But is the fish bigger or a hen bigger? And therefore I have to consider two diagrams. Or I can be a smarter version and can draw two concentric circles and can include bird in between. So now birds also become the part of fish, and birds also become the part of hens. I mean, by common application. This is nothing as a trick, but by common application, I think by common sense, we can reach out to it that, okay, all the birds are also fishes and all the birds are also hens. Now, some of the fishes are hens, some of the fishes are hens. I mean, necessarily yes, because minimum one bird is also going to be always a fish and a hen. So one fishes, which is the bird, is always going to be hen. So I think this is something that we can say. And if you recall my universal rules, I think two universal can give us a universal and a particular, two positive can give us a positive. So there is no scope of negative that no fish is a hen, because obviously a bird is a common element between the fish and the hen. So this is definitely wrong, and the first is true, and therefore the answer is going to be A. Let's move to the next one. All trucks are scooters, all cars are scooters. So again, the scooter is a common element which is included. So let's say all the trucks are scooters, and then all cars are also scooters. Now, interesting one. Now, cars are also inside the scooter, therefore I have no intersection. I don't know if I draw least intersection, I'm going to cover the car here. So my cars are not necessarily going to intersect the truck. However, my car can be here and my car can be here, right? My car can be here as well, my car can be equal to this as well. So there are all these possibilities, but I'm for the sake of positive conclusion, I'm going to take this as a negative, as a least intersection diagram, and then say some trucks are car. Oh, I'm sure that in least intersection diagram, no, so this is gone. And then some trucks are not cars. Oh, now two positives cannot give us a negative. Remember, u plus can't give us a negative. Okay, this is only will give us u and p positive. So this claim is definitely invalid. So again, neither of the claim is true. So the one quickly I drew with respect to the diagram, and for the second one I used my memory, remember the rule, and I turned out. So a C is the correct answer. Let's move to the next. All Amazons are Flipkart, some Amazons are not Snapdeal. So whenever there is a negative, try to draw that first, because see, I can see the least. So try and draw the maximum intersection diagram, because these are the negative conclusions as well. So let's draw that Flipkart is this. So this is the Flipkart, and this is my Snapdeal. So some of the Flipkarts are not Snapdeals, but that's the maximum intersection happening. And then all Amazons are Flipkart. So Amazons are also inside the Flipkart. Okay, so maximum intersection. All Amazons can be Flipkarts. Maximum intersection diagram. Why did I draw MID? Because of this, a negative conclusion. As there are negative conclusions, I have told you, whenever you see a negative conclusion, for a negative conclusion validity check, draw MID. For a positive conclusion validity check, draw the LID. So I'm sure that you understood. I'm drawing MID now. Let's check for the NID. Some Snapdeals are not Amazon. In this case, all the Snapdeals are Amazon. So this is gone. Now, some Amazons are not Snapdeals. Some Amazons are not Snapdeals. I think that is going to be true. But in the case where you said that, all Amazons are Flipkart. So Flipkart is this set. But if I would have made an Amazon like this, okay, that Amazon, let's say Amazon 2. which is the maximum intersection. Amazon is equal to Snapdeal because Amazon is supposed to be inside Flipkart as a subset, right? This is the maximum intersection. I'm now taking Amazon and Snapdeal ka maximum intersection. So in this case also you will not be able to say it for sure, and therefore neither of them follow. But I hope you have made a mark that how did I check? In this case, you would have said in this diagram, you could have said some Amazons are not Snapdeal. But if I make Amazon as a subset of Snapdeal, there is a possibility there where we cannot say this. And for this to be definitely true, guys, you know that it needs to be true for all the possibilities. So that is where it should not be even false at one. So either check where it is false or either check for all possibilities. In both the cases, you will end up drawing more than one diagram. So I think in this case, you would have realized this fact that, okay, Amazon can be equal to Snapdeal, and in that case, this possibility will not be true, and hence this claim is an invalid claim. Moving ahead, next one, again, some Snapdeals are not Flipkart. Okay, he's reversing, and then again, not and not. So let's quickly check. Let's make this time Snapdeal a bigger set, and then Flipkart. This is the Snapdeal, and these are not Flipkarts. Okay, now all Amazons are Flipkart, so all Amazons is equal to Flipkart. Okay, now all the Amazon can be inside this also. So all Amazon is equal to Flipkart, or Amazons is a subset of Flipkart, right? Now some Snapdeals are not Amazons. I mean, that is always going to be true because some of the Snapdeals are always going to be outside Amazon in any possibility for that matter you can consider, because some Snapdeals are not Flipkart. So some Snapdeals are always I mean, this is only going to be false at when Snapdeal is equal to Amazon, which cannot happen because Snapdeal cannot be equal to Flipkart because of this. You can't make this diagram and say, okay, Snapdeal is not equal to some Snapdeals are not Flipkarts, right? So I'm sure this is going to be always true. While some Amazons are not Snapdeal, some Amazons are not Snapdeal. I mean, that is not ridiculously true because all of the Amazons can also be Snapdeals. In this case, only A is valid, and therefore answer is A. Let's move to the next one. Now, every is taken as all, so all students are philosopher, and at least one is taken as some. Okay, when I said, and when some arguments or statements or propositions do not look like this, you should convert it to their logical equivalent. So all student is philosopher, all student is philosopher, and one astronomer is a student. So at least some astronomers are students. So at least some astronomers are students. So I don't know how big is the set of astronomer. So I can make it like this. I can make it like this. I can even make it like this. Just drawing for fun, okay, as an encompassing possibility. Now, every philosopher is a student means all philosophers are students. Are all philosophers students? Definitely not. Remember, all A or B is not equal to all B or A. So if all students are philosopher, I can't say all philosophers are students. So that's wrong. That's also an immediate conclusion coming from only the first one. Then some philosophers are astronomers, some philosophers are astronomers. I think that is always going to be true because some of the astronomers are always going to be student. At least one astronomer is a student, and student is always going to be a philosopher. So I think at least one astronomer is always going to be a philosopher. So this conclusion is definitely true, and therefore Bombay becomes the correct answer. Moving ahead, the 12th one, no cattle is kettle. As I said, draw always the negatives first. So no cat is kettle. All right, some kittens are cats, so some kittens are cat. So I have no idea how big is the set of kittens. So I'm going to make kitten 1, and I'm going to also make a dotted diagram where kitty can touch the cattle, and also where it can encompass everything. So let's say like this also, where kitty can be kitty infinity. Okay, the kitten's infinity. Some cattles are not kittens. Okay, this is interesting. Some cattles are not kittens. I'm thinking, yeah, because, okay, no, interesting. Some kettles are not kitten. So he's saying kettles are always going to be outside kitten, but in the kitty infinity, this is not. So let's check it at MID, where the kettle is encompassed in the kettle. So at a maximum intersection diagram, the kettle, some of the kettles are not kitten. Actually, the opposite. It's some of the kittens are not kettle. So this is wrong because all of the kettles are now kittens. But some kittens are not kettles. Okay, now this is interesting. Some kittens are not kettles. Okay, let's check it at kitten 1. Yes, see, some of the kittens is not a kettle. At kitten 2 also, some of the kittens will not be kettle. At kitten 3, yes. At kitten infinity, yes, these are the kittens that are not kettles. So this is very interesting. So you can just pause it for a while, understand it, and envisage it. I usually explain this to my students as this way, saying that whenever you have these two cases, try to convert it as a universe and earth set. Because I think I can say, so in this case, the universe is kettle. Okay, I'll explain this. What do I mean by universe and the earth set? Uh, See, it's funny to say some earth is not universe, but it is not definitely funny to say some universe is not earth. I mean, does that make sense? This doesn't make sense, this does. So try to think which set can be enlarged. That part of certain set can be outside the smaller set. In this case, which was my universe, the universe was the kettle. Why? Because some kittens were cats. So cat has an intersection because cattle has a restriction with cat. So cattle cannot grow, and whatever it can grow, it cannot touch cat. So there is kittens which can grow, and then some kitten kettle is the one which can. The kittens is something that which can become the universal set, and then cattle is my earth. So I'm saying some earth is not universe, wrong. I'm saying some universe is not earth, right. And therefore, I think in any possibility you can always say some universe is not earth. So that's what my logical explanation for it is. I hope you'll understand it. Man is van is vehicles, not men. So definitely from two positive, we cannot get the negative. And then they are men. Let's check. Man is van is vehicle. So man, van, and vehicle. I think the vehicle is man. So yes, in all possibilities, we can say the two. Therefore, the answer comes as Poppy. Let's take the next. The 14th. All characters are protagonists and some characters are not protagonists. So not, let's draw the not first and the maximum intersection diagram. So let's say these are my actors and these actors are not protagonists. Okay, so these are the actors that are not protagonists. And then all characters are protagonists. So characters somehow inside. Characters inside protagonists. So some characters are not actors, some characters are not actors is going to be false. Because all of the characters are actors in this case, so this is wrong at MID. And then all characters are actors. All characters are actors is kind of true, but at a MID. Let's check for least intersection diagram now. Why? Because this is a positive claim. So let's draw this as this now, that I have certain actors which are outside. So some actors are not protagonists, so these are the protagonists. And then all of the characters are protagonists, so all of the characters can be here. Least intersection diagram now. Now, can you say in this case all of the characters are actors? Definitely not. So this I checked at LID. Why? Because this is a positive claim. Both the claims are not true and therefore C. I hope I made it. Sometimes, they can make you draw multiple diagrams. So be flexible. Don't be rigid that I have to only draw one. And I've given wishes to win, which is to which. I think for the negatives, draw the MID. And for positives, draw the LID. Last question. Take a 3-1, but please remember no, then all, then some. You might be wondering why, how. I think during revisions, during drawing diagrams, we should keep this in mind. Try to draw the negatives. Then universal, it keeps the diagram serene. That's it. Okay, let's look at the last one. No apple is banana. So no apple is banana. So no apple is banana. Then all the oranges are apple. So all of the oranges are apple. Now I know orange can max be till apple. And then finally, some of the grapes are oranges. Some of the grapes are orange, but I have no idea upon how big is the grape. Okay, because grape is another set. So how many sets are there? Orange 1, apple 2, banana 3, and grape 4. 4 variables. Okay, so let's put grape. I'm drawing a grape least intersection here. Grape 1, but grape can be like this also. So this is my grape 2, and grape can encompass everything also, right? Because there's a maximum possibility that can happen. You have no idea how big is the grape. You're just saying some grapes are oranges. Sorry, grape infinity. So some grapes are not bananas, some grapes are not bananas. True, because again, this isn't this a universe kind of a situation? The grapes are the universe and the banana is the earth. So some universe is not earth. In any possibility, can you make a grape equal to banana? Think about, in any possibility, can grape be equal to banana? Because grape has to intersect orange, and orange is inside apple, so orange cannot be maximum go outside apple. So in any of the case, you cannot draw banana and grape to be equal, which would have nullified this. So this is definitely true. So one is true. Now no orange is banana. No orange is banana. I mean, that is true, because orange can maximum be till apple, and none of the apple is banana. So I think that is also true. I am just checking it from this diagram. Some apples are grapes. Some apples. So this is my apple and this is my grape. Now, because some of the grapes are always going to be orange, I think, and all oranges are apples, some of the grapes are always going to intersect this apple guy. So that's true. Then some grapes are apples, because if some apples are grapes and some, so isn't this the reverse of this? Some apples are grapes and some grapes are apples. So I think this is also true, and therefore all the 4 conclusions are correct. So do not be overwhelmed by, if they give you multiple combinations. If you just follow my tricks to draw and quickly check, I believe you will be just fine. I think that's all from my side, guys. See you in the next video. Thank you so much. I hope you made some progress solving syllogisms. Thank you so much. Take care. See you in the next video.